Hey, yo! Yo, what's up, guys? It's Mr. G coming at you live from here at the Poly Middle School. And we're going to talk about proportional relationships and their graphs. And this should be 4.3. Already noticed a mistake. It's all good, though. Okay. So, we're going to use and represent proportional relationships. And we're going to represent them, and we're going to analyze them, and we're going to talk about what's proportional, what's not proportional, how we determine something's proportional, and we're going to look at graphs when we do it. So first we got to talk about what an ordered pair is. Ordered pair of the x and y values on a graph, so it looks just like this. Okay, so we'll see the point, and I'll make one up here, 2, 1. Could be a possible ordered pair. And with 2, 1 as an ordered pair, here's your x value, here's your y value. We use that to plot points. And then the origin is the point 0, 0 on a graph. That is just a unique ordered pair because we use the origin a lot. Now, so what we're going to be doing is we're going to be looking at proportional relationships and graphs and determine if something is proportional just by looking at a graph. So a relationship is proportional, so this is right here, if its graph is a straight line that goes through the origin. Okay, that is a key point to what we're talking about today. So it's proportional if it's a graph is a straight line that goes through the origin, and that is it for looking at graphs and determining if it's proportional or not. So here's a few examples over here for proportional relationships and non-proportional relationships. Here's the origin at 0, 0. I have a straight line that goes through the origin, so therefore it is a proportional relationship. Okay, if I take every single one of these ordered pairs here, it's like looking at this ordered pair, my y is 1, my x is 6, so I have the point 6, 1. So if I do y divided by x to check to see if it's proportional, I'll get 1, 6. Now if I go over here, I have 30 and 5, so that's 530. Well, if I do y divided by x, which is how we learned in the last video of how to check for something's proportional, y divided by x should always be the same. And I'm sorry, these are backwards, by the way. Come on, Mr. G. So this would be x was 30, y was 5. Y divided by x right here, y divided by x would be 5 over 30, which is also equivalent to 1/6. So proportional, if I did that for every single one of these points, I would get 1/6 when I did y divided by x. So it is a proportional relationship. So now for non-proportional relationships, that wouldn't work. The y divided by x wouldn't work. But it's also not a straight line, and it doesn't go to the origin. This right here, this does go to the origin, and it starts as a straight line. So it looks like it could be proportional, but then it starts to curve. Once it starts curving, it is now no longer proportional. Okay? So it's just as simple as looking at if it's straight or not straight. Now also I have another example over here of non-proportional relationship where we have a straight line but it does not go through the origin. Okay, this does not, the origin is right here at 0, 0. This line does not start at the origin, so if I were to actually check my points and do y divided by x, they would not equal the same. They would not be a proportional relationship. So for example, here, y is 10, x is 1. So there's my first point is 110, and let's look at this last point right here. This last point right here is 425. Well, if I do y divided by x, 10 divided by 1, y divided by x, right? So here's my y, here's my x. That's 10 over 1. Is 25 over 4 going to simplify to 10 over 1? And the answer is no. Okay, it will not, because it's not a proportional relationship. So one thing, you do not have to check y divided by x when you're looking at a graph to determine if it's proportional. If you see that it's a straight line that goes to the origin, like this one over here, then you're good to go. So if you see it's a straight line that goes to the origin, it's automatically proportional. You don't have to do the math. That math is just to show you, to prove to you that they're not proportional. They are proportional based on what we learned last time. Okay? Now, so we have a house cleaning company, and we're going to talk about whether or not this is a proportional relationship. Now, this house cleaning company charges $45 per hour. We want to determine if it's a proportional relationship, but then we want to graph it, and then we want to write the equation, because all three of these things represent the same thing. This table right here, if it's proportional, we can place it onto a graph, and then if we place it on the graph and if it is proportional, we'll also have an equation for it. And all three of them work together for proportional relationships. So let's look at it. $45 per hour. So for 1 hour, that means the total cost would be $45. So for 2 hours, if it's $45 per hour, for 2 hours, that would be 45 times 2, because that word per hour right there. Per hour means we're going to multiply, which will cost 90. Bam. 3 hours, 45 times 3, 135. For 5 hours, 45 times 5. Let's work that out real quick. I get 25. I get 225. Okay. For 8 hours, 45 times 8, because it's $45 per hour. 32. It is proportional because we just did the multiplication and figure it out. So it is a proportional relationship. Okay, we know that because this is $45 per hour. That cost never changed. So we just multiplied 45 by the amount of hours each time. The unit rate. Here's my unit rate, or my constant of proportionality. If I did y divided by x each time, 45 over 1 equals $45 per hour. 90 over 2 equals 45 per hour. 135 over 3 equals 45 per hour. So the unit rate, or the constant of proportionality, those are the same thing, is 45. So my equation is y equals 45x. Now if you don't know how I got that, that is from our last video that we watched. Okay, so from our last video, we had to do y divided by x over here to figure out what our constant proportionality is, what our constant rate of change is, and then we use that information to plug into the equation. Now, I want to plot these points. So if I look, I have my x values and I have my y values here. So if I have my x values and my y values, I'm going to plot them on my graph. And we already have the graph labeled. I have time and I have total cost. So after 1 hour, we know it's about 45 bucks. So I can place it right there. Now I know it's not exactly 45, but it's really close. For 2 hours, we're at 90, so it's going to be just below 100. For 3 hours, 135. Right about there. For 5 hours, we were at 225. So right now I'm just plotting my points that we created. This is an x, this is a y, right? These are all ordered pairs. So if you're confused where I'm getting these points, this is an ordered pair of 145, which is where I got this point right here, at 145. Okay, this is the ordered pair of 290. Okay. So where did I leave off? Sorry, I'm at 225, so now I got 8 and 360. Zoinks. Somewhere up here. If we look, if I were to connect all of these, I know we were kind of doing, we didn't have an exact graph, but if you see, they still make a straight line. And if I continue the graph, it would have gone right to the origin. So I do have a proportional relationship. We determine that by looking at our table and doing y divided by x, getting 45 each time. My equation was, of that constant proportionality, was at $45 per hour. That was the unit rate. And my graph makes a straight line that goes through the origin. Okay. So now we have a graph that shows a relationship between time in minutes and the number of miles Damon runs. Write an equation for this relationship. So you might have to look at a graph. So I might have to look at a graph like this and determine what this equation is just by looking at the graph. Okay. So right away we know it's proportional because if I connect all the points, it makes a straight line that goes through the origin. So what we need to do is we need to pick these points, and so I know it's proportional. So now I just need to pick any point, because the fact that I know it's proportional, if I take y divided by x on every single one of these, it's going to give me the same answer because I already know it's proportional. So I don't have to check all of them. I just have to pick one point. That looks like it's going to be pretty easy math, and then that's going to be my constant of proportionality, or my unit rate. And the best point to pick should probably always be the lowest numbers, probably. Especially when we have a 1 involved. That's always nice. So if I take this point right here, x is 10, y is 1. Okay, I have x is 10 right here, y is 1. So this is y divided by x. So if I have the point 10, 1, and I need to do y divided by x, well, here's my y. So this is going to be 1 over 10. So my equation is y equals 1 over 10x. And let's think about what the 1 and the 10 represents. The 1 represented miles, and then the 10 represented minutes. So it's taking them 10 minutes to run 1 mile, and that's their rate. Okay? All right. And that's it. So I just want to, hold on, sorry, I just realized. I just want to mention, so all you have to do is pick one point. I cannot stress this enough. You do not have to check this for every single one. The rate will be the same, 1 over 10 each and every single time. You can also leave it as a fraction. So I can just leave it as 1 over 10x. I could change it to a decimal if I wanted to, and I could make that do 1 divided by 10 right here. I could, because decimals are the same thing. Once it's just a number written as a different way. And I could make it 0.1x. That shows the speed, and that would work as well. But no problem with just leaving it as a fraction, so you don't have to do any division. All right. So this graph shows a relationship between the distance a bicyclist travels and the time in hours. Okay, so distance a bicyclist traveled and the time in hours. What does the 0.460 represent? What is the constant of proportionality? What is the equation? Try this one. Pause it and see how you do. Okay, so I got the 0.460. First, we know it's proportional. Straight line goes through the origin. Okay, so now I have the 0.4 and 60 right here. What does that represent? Well, that represents 4 hours, and it represents 60 miles. So that shows that 4 hours, the bicyclist traveled 60 miles. Okay, and that was when I would actually write it in a complete sentence. In 4 hours, the bicyclist. In 4 hours, the cyclist went 60 miles. That's what that point represents. Okay, it tells me exactly after 4 hours how far they've gone. What is the constant of proportionality? Now I have a point. We have this point right here, right? I could use that point since I'm already on it, and I know it's a perfect point. If I look at the rest of this graph, like this right here, this is not a perfect point because it's in between this line and this line. So I don't know exactly where this is. It's more of an estimation. We don't want to do that. We want the perfect points like this one, where it's exactly on this line and that line. But this one, 460, we already know what it is. It's perfect, so I can do y divided by x, which is 60 over 4. I can do 60 divided by 4, or I can just simplify my fraction, but I would get 15 over 1. So that would be 15 miles per 1 hour. That is the constant proportionality. That is the rate. That is the speed at which the cyclist is riding. So therefore, my equation is y equals 15x. Okay. Now, things to remember. Jot 1 or 2 things down. I'm actually going to be checking this. So put down 1 or 2 things that you think are important to remember, and I'm going to check that when I'm looking over your notes. Independent practice. Tell me if this is proportional or not. Why or why not? And that's it for today. Thank you for watching. If you guys have any questions, let me know. And good stuff. All right. Good DS.